In section 4.2.2, we'll be defining the product of matrices. I'm going to start with two matrices. I'm going to start with A, which is going to be an M by K matrix, and B is going to be a K by N matrix. Their product, AB, will be an M by N matrix. So notice that I need that middle dimension here to be the same. So the number of columns of A is the same as the number of rows of B. All right, so let's define AB. I'm going to spell out A in a specific way. I'm going to look at each row of A and think of those as separate vectors. Since A has M rows, I'm going to have M of those. Then I'm going to look at B. In the case of B, I'm going to look at each column as a separate vector. Since B has n columns, I'm going to have n of those. Now, to define the product, I'm going to end up, like we said, with an M by N matrix, and its entries are going to be obtained by taking the dot product of the row of A in which you are and the column of B in which you are. So if you're in the entry ij of AB, you're going to take the ith row of A and the jth column of B. One thing to note is we've asked that these middle entries be K. So since the number of columns of A and the number of rows of B are equal to K, these vectors are all in Rk, and so the dot product exists, and that's why we can define AB this way. If the numbers were different, if the number of columns of A is not equal to the number of rows of B, then AB just does not exist. It's not defined. All right, let's try one. Let's try AB. So I have 1, minus 2, 3, 4, and I want to take product of that with B, which is 1, 2, minus 2, 0, 1, 3. All right, so let's check the dimensions. A is a 2 by 2. B has 2 rows and 3 columns, and notice that that middle dimension match, so this product is defined. I'm going to get a 2 by 3 matrix. Let me just write, I'm going to pretend like this is the D matrix because A, B, C are already taken. So I'll have a 2 by 3 matrix. So I'm going to have 6 entries. That are labeled this way. To figure out what they are, let me give colors to the vectors that we're looking at. We're looking at rows of A. So there are 2 rows. Let's use yellow and orange. So I have the 1, 3 vector. I have the minus 2, 4 vectors. And for B, I'm looking at the columns. So I'm going to have 3, 1 green, 1 blue, 1 purple. So according to the definition, the row you're in tells you which of the vectors of the first matrix to take, and the column you're in tells you which one of the columns of the second matrix to take. So if I'm at D11, I'm told to take the first row and also the first column. So first row is yellow, first column is green, and so I'm going to take the dot product of 1, 3 and 1, 0. So I'll get 1 times 1 plus 3 times 0. That's what happens when I take yellow times green. Now for D12, my I is still 1. That's the first number, so it's still 1. So it's still yellow, but I'm in the second column, so I should take the second column. So I should take yellow and blue. For the second entry here, it's going to be 1 times 2, so yellow times blue, plus 3 times 1. All right, for the third, it's going to end up being yellow and is 3, so purple. So let me just spell out what it is. Minus 2 plus 9. Sorry, I'm a bit low on room, so I won't actually write the products, but it's 1 times minus 2 plus 3 times 3. All right, so for the entire first row, you use yellow. For the entire second row, I is equal to 2, so I will be using orange. All right, so the second row is completely orange, and then depending on the column I'm in, I'm going to use either green, blue, or purple. All right, so the column you're working on tells you which column of the second matrix to take. The row you're working on tells you which row of the first matrix to take. All right, so orange times green, that's minus 2.1 plus 4 times 0. Orange and blue, that's minus 2 times minus 2, that's minus 4 plus 4. And then I get 4 plus 12 when I take orange and purple. And so here I end up with 1, 5, 7, minus 2, 0, 16. Whew. All right, so it's a bit tricky at first to keep everything straight, but it gets easier. All right, let's try BA. The more practice you do, the more comfortable you'll be, the faster these will go. So BA is like this. Let's label them the same. Oh, sorry. I have a first row here. I have a second row here. First column, second column. So my first entry, again, will be first and first. So first and first. So wait a minute. So I'm going to take this vector and this one. I want to take their dot products, but they're not in the same dimension. I can't take something in R2 and something in R3 and take their dot product. So this matrix does not exist. I can't do this product. In fact, I wasn't careful. This is a 2 by 3. This is a 2 by 2. I didn't check because I wanted you to see what happens when it doesn't work. But these middle dimensions don't match, so the product doesn't work. All right, let's try the next one. In C, I'm asked for BC, so 1, 2 minus 2, 0, 1, 3, and then C is 5, 1 minus 1, 1, 3, 1. Let's color them again. Yellow, orange, green, blue, and so I will get, let's see what I have. This is a 2 by 3, a 3 by 2, so I'll get a 2 by 2. Let me spell out what the entries are just to make sure everyone is following since I cannot see you guys. This is going to be yellow, yellow. This is going to be orange, orange. My green is going to be the first column, so everything in the first column would give green, and then blue for the second column. And so yellow and green, that'll be 5 plus 2 plus 2. Yellow and blue, that will be 1 plus 6 minus 2. All right, then I get orange and green, that's 0 plus 1 minus 3. Orange and blue, that's 0 plus 3 plus 3. And I get 9, I get 5, I get minus 2, and I get 6. See, that was already quicker. All right, let's try one more. This one is a weird case because I have a 1 by 3 matrix times a 3 by 1. The product is defined because these middle dimensions match, but then I'm left with a 1 by 1 matrix. So that's a matrix with a single entry. That entry would be D11, and so it would be the product of the first row with the first column. So it's really very similar to just taking the dot product of two vectors. It's just that one is written as a row and one is written as a column. So 3 plus 1 minus 2, that's